What we're going to learn in this section is just a new way to label functions. And the reason we need to learn a new way to label functions is sometimes we're going to deal with more than one function. So we need something other than y equals. We can't just say y equals over and over again. So what we're going to be using is function notation. That's going to look like this. Instead of saying y, we're going to say f of x. F of x. F of x. The first thing to really pay attention to here is that this does not mean multiplication. Does not mean multiplication. The way you say it is f of x. And what does it mean? It means f is the name of the function. This could be anything. We could call it Bob if we wanted to. Bob of x. But the most common name for a function is going to be f. X is the value from the domain, the set of all input values, the things you can put into the function. And f of x is the function value, or y value, that corresponds to the x. X is the input, y is the output. The key thing to realize here is f of x is just another name for the dependent variable y. So saying y equals 9x minus 5 is the same thing as saying f of x is equal to 9x minus 5. The same thing. It's just another name. So you could be asked, let f of x equals 9x minus 5. Okay, we looked at that before. Find the value of the function f for x equals 2. All this means is you're finding f of 2. What that means is you're plugging in 2 in for x. That's 9 times 2 minus 5. So that's 18 minus 5. Which is going to be equal to 13. You now know the function f evaluated at 2 is 13. Keep in mind that we didn't multiply 2 times f. We just plugged in 2 for x right there. So again, what are we talking about here? Y, another name for y, is f of x. F is going to be the name of the function. Y and f are y and f of x are the value, the output values of the function. And x is the name of the independent variable, the input set. And this is the defining expression for the function, the rule. What are you doing to x to get the output y or f of x? So here's another one. Let f of x equal negative x squared plus 5x minus 3. Solve the following. This means plug 4. This means plug 4 in for x. So it's f of 4 is going to be negative 4 squared plus 5 times 4 minus 3, negative 16 plus 20 minus 3, negative 16 plus 20 is 4, so 4, well not 4 plus, 4 minus 3 is going to be 1. So that tells us that f of 4, when you plug 4 into the function f, you get 1. What does this one mean? F of q. Well, q isn't a number, but does that change anything? No, it just means we're plugging q in for x. So f of q is just going to be negative q squared plus 5 times q minus 3. Now, we can't simplify that, but that is what it's asking. F of q equals what you get when you plug q in for x into this expression right up there. Now, can you plug anything else in? Sure. Let's say we had g of x is equal to 2x plus 3. Find and simplify g of a plus 1. All that means is plug a plus 1 in for all instances of x. Well, there's only one instance of x right there. So g of a plus 1 is going to be 2 times a plus 1 plus 3. Which we can simplify a little bit. We distribute and get 2a plus 2. That plus 3 is there. We end up with 2a plus 5. So that tells us that g of a plus 1 is equal to 2a plus 5. So here's another example. Find f of 3. That means plug 3 in for x. So f of 3 is 3 times 3 minus 7. 9 minus 7 is 2. So it's really just plugging things in. F of 3 is equal to 2. So if this represents the function f of x, what is f of 3? meaning when f of 3 means it's asking when x is 3, what's y? So where are the x values in all these coordinates? Well, there's the x value there, 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 and there. Oh, look, there's 3, f of 3. The x equals 3 there. So what does x equal when x, what does y equal, the output? What does the output equal when x is 3? We'll look right there. So from that table we can tell that f of 3 is equal to 1, because the table, the set of points, not the table, the set of points tells us so. But what about this way of representing a function? It's showing that 2 maps to 6, 3 maps to 5, and 10 maps to 12. So when it asks, when you plug 3 into the function, we take 3 from the domain, 3, what does that equal? Well, it tells us right here that when you start with 3, it ends up with 5. So with this function, f of 3 is equal to 5. What happens if you had a graph? What happens if the graph was given to you and it said, what does f of 3 equal? Well, you go to where x is equal to 3, which is right there, there's 3, and you ask yourself, if you go up here, what y value am I at? What y value, there's the x value right there, what y value does it correspond to? Well, it sure looks like it's 4. Now, it's impossible to tell exactly on this graph, but it really looks like this point right there is the point 3, 4. So when x is 3, what's y? You can tell from this picture that it's 4. So what about this question? Same graph, says what's f of 3? Well, again, we do the same thing we did before. We go up, find what does the output value equal? Well, it does equal 4, like it did before. But similarly, what is f of 0? Well, you start at 0 right here, and you go up. Where are we right here? What's the output value? Well, that's 1, because we're at a height of 1 if we start at an x value of 0. Well, it gets a little bit more fun, because instead of going from x to y, we could go a little back. We could go backwards. For what value of x is f of x equal to 5? In that case, you start at 5 here on the y-axis, go over, and then say what x value corresponds to that y value. Oh, it's 4. So f of 4 is equal to 5. So for what x value? That's 4. So what happens if you get a function in y equals form and you want to put it into function notation? Well, the first thing you need to do is solve the equation for y, and then replace y with f of x. So in this case, if we want to write that one, a, in function notation, first we need to check, is y isolated? It is. So all you need to do is replace y with f of x. It'll be f of x is equal to x squared plus 1. So then what does f of negative 2 equal? That means you're plugging in negative 2 for x. Put parentheses where x is. This is super important because you're squaring the x. So you're squaring the negative 2. So that's going to be negative 2 times negative 2 plus 1. So that's going to be 4 plus 1, which is 5. So now you know that f of negative 2 is equal to 5. What about over here? Is y isolated? Well, before we jump to that one, let's do f of a here on this one. All that means is instead of x, you're writing a. So that's going to be a squared plus 1. Now, let's work on this one. We need to isolate y first. Let's subtract x. You get negative 4y is equal to negative x plus 5. So we subtracted x from both sides. And then divide both sides by negative 4. So y is equal to negative x over negative 4 plus 5 over negative 4. Negative over negative is a positive. So we end up with y is equal to x over 4 minus 5 over 4. If you really want to go a little further, you could say y is equal to 1/4 in parentheses x minus 5 over 4. Now that we've isolated y, if we want to write this in function notation, we replace y with f of x. So we have f of x now equals 1/4 x minus 5/4. This question asks us to find f of negative 2. So you plug in negative 2 for x. So you get 1/4 times negative 2 minus 5 over 4. It's going to be negative 2 over 4 minus 5 over 4, which is negative 7 over 4. So now we know that f of negative 2 is negative 7 over 4. Last, it asks us to do f of a. F of a. So if we have f of x is equal to this, f of a is going to just be what you get when you plug a in for x. So 1/4 a minus 5 over 4. And you're done with that problem. So now in this section it goes on to tell you that a function can be defined by f of x equals ax plus b. This should look really similar. This is just y equals mx plus b form, which is just slope, intercept. And the only difference between this form, slope-intercept form, and what we have now is that instead of y, we have f of x. Instead of m for the slope, they're using a. And this is, they're also reminding you that a and b are real numbers, and when you write a function like this, it's a linear function. A is the slope, m, I don't know why they changed it, but of the graph, and the domain of this is all real numbers. This is all real numbers. You can plug any number you want in for x. So if the question was to graph this function, you know immediately that the slope is 1/4, and the y-intercept is 0, negative 5/4. So if you were to graph this, you would start at 0, negative 5/4, and go up a slope of 1/4. That's up 1 over 4. So for every unit you go up, you go over 4. So let's say you went up 1 over 4 right here. And there is your graph. Because I'm kind of approximating this, I'm calling this slope 1/4 right here. This slope 1/4. For every unit up 1 you went, you have to go over 4. So the big point here is that we're just giving the function a name. And in this case, we're giving the function the name f. And the way you say it is f of x. And remember, this is not multiplication. This is just a new name for the function. All the rules that we knew before still apply.